A postulate, as we saw previously, a postulate is a statement we take to be true without proof.
Sounds like you got pretty reasoning.
Okay. Sorta. It's more in tune with what's called an axiom. It's very similar to an axiom or the basic rules of our system, the basic rules of what should be going on. Okay, and a postulate is one of those rules that it's just there. It's there. It's true, and we're going to build off of that. Is a postulate. Okay. So let's book through these as quick as we can. Our first new postulate says that through any 2 points, the following is true. If I give you 2 points, then there exists a unique line through them. Postulate 6 is basically the converse of this. So if you have a line, then what do we know should be true? Contains at least 2 points. Okay. Postulate 6 is basically the converse. If you have a line, then it has at least 2 points. Is the next step from that. If 2 lines intersect, what should the intersection of 2 lines be? What should be? What do we? If you see 2 lines intersect, what do they form? A vertex. So more specifically, what is a vertex?
A point.
A point. So if 2 lines intersect, then they intersect at a point. If they intersect, then that intersection is a point. It has to be. What do we say was true about any 3 non-collinear points? What do we say we could create if we had 3 non-collinear points? A plane. Through any 3 non-collinear points, there exists a unique plane. If you have 3 non-collinear points, then you get yourself a plane. You should be able to construct that. A unique plane.
Oh. Wait, is a plane, does it use the points as like the outside, or they just
in it.
draw like any shape?
Any. Yep. A plane just goes on in both directions forever, and it contains those 3 points that we say in infinitely anymore. So then, if we have 3 unique points, if we have 3 non-collinear points, then there's a plane. If we have a plane, then what do we know?
Definitely 8 points.
Then there exists at least 3 non-collinear points. Postulate 10 talks about the location of a line. So if 2 points lie in a plane, then where should the line going through them be located? If 2 points are on a plane, where should the line that connects them be located? On that plane. If 2 points lie in a plane, then the line connecting them, or through them, through is a better word, and the line through them is in the same plane. Last but not least, if 2 planes intersect, then the intersection is a line. So for example, if I give you a diagram, what postulate is being used here? If I give you this, then this new picture, what postulate here is being used?
7.
7. Number 7 says, if two lines intersect, then they intersect at a point. If here's two lines intersecting, therefore there's a point. This would be number 7. If you have 2 points, then there's a line through them. That's what, number 5? Number 5 is what's being described in this picture. Okay? Then you'll take this info and figure out what new we can claim. Okay? Rules for interpreting a diagram is this. Oh, it's the last piece here, and we're not going to get through the diagram here. But rules for interpreting. Keep in mind when you're looking at a diagram, things you're allowed to assume and not. The biggest rule is that only assume measures of angles and segments if written. Don't ever just assume. So for example, on this diagram, you can assume that A, G, and H are collinear. You can assume that you have a straight line here. You can assume you have a linear pair. You cannot assume that, say, these 3 are collinear, because that was not drawn in. You could not assume that this point is on the same line as these 2, because I didn't draw it in. Okay? You can't assume that any 2 angles, even though this one and this one look alike, we can't assume that those 2 angles are the same measure, because I didn't tell it to you. It's not written in.